This is Adam Glassifer with a problem statement and literature review presentation for E4 732, Implantable Medical Device Security, Threat to Patients, Clinicians, and Healthcare Organizations. Problem statement. With the advancement of technology in implantable medical devices, or IMDs, security concerns have been largely ignored throughout this time. Currently, there are 2.5 million patients in the United States who use IMDs, and essentially are using devices with insecure wireless connectivity. Much of the problem has to do with the fact that there are no standardized measures that address authentication concerns. A comparison of proposed security measures focused on authentication will offer an evidence-based security recommendation. Literature review. The history of IMDs. In 1952, the first successful placement of an external pacemaker was performed. Over the next 8 years, efforts were made to implant the pacemaker, and this was successfully performed in 1960. From 1960 all the way up through 1980, efforts then transitioned to improving upon current pacemaker design and establishing a defibrillator that could be implanted successfully, which was achieved in 1980. Since 1980, there have been vast improvements in technology, design, and functionality of IMDs. However, over this time, there's been no formal or standardized FDA regulations on security measures required for IMDs. Literature review. IMD security and privacy issues. Wireless connectivity of IMDs allows for significant patient autonomy in that they can connect with their physician, with programs, with monitors, and various other platforms. However, this makes the implant remotely detectable. So that means that in the Internet of Things, a hacker or someone illicitly trying to gain access could see the implantable medical device and potentially gain access to it. This unauthorized access could then be used to control the device, which ultimately places both patient data and patient status at risk. This could be used for financial gain or to commit terrorist or criminal acts. Literature review. IMD resource constraints. The small design of IMDs for implantation significantly restrict resource capabilities. Battery, storage, and memory are all limited due to the size of an IMD. This significantly limits computing and communication abilities. Improving upon any of these capabilities would increase the size of the device and decrease overall battery performance. This is important because battery performance is of significant concern, since any time a battery needs to be replaced, it essentially is a surgical procedure. This means the patient is undergoing anesthesia and other risks simply to replace the battery of the device. Literature review. Proposed IMD security measures. The focus on many of these security measures is placed on authentication. The proposed measures include things like dual-factor authentication, certificates, near-field communications, biometrics, anomaly detection, and external devices. Several authors have proposed and studied an external device to serve as a wireless security layer for IMDs. Literature review. Summary. IMD security and privacy issues exist largely due to inherent design limitations. There have been various proposals for security measures to address authentication concerns. However, there's been no real side-by-side comparison looking at which method is best from both security and resource usage standpoints. Discussion questions. Although there have been no real-life occurrences of IMD hacking, does the potential for illicit use of these devices concern you? It's worth noting that there have been several demonstrations that show that the ability to hack these devices is very real and very possible. Also, what evaluation design elements do you think would be most helpful in evaluating the proposed measures? Thanks for taking the time to watch my presentation. I look forward to your feedback.